representing real numbers. This example, we are going to use the appropriate Taylor series to find the first four non-zero terms of an infinite series that is equal to the cosine of the value 2. The function that we use for this problem is the cosine function. So f of x equals cosine x. The Taylor series expansion of the cosine x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the 6 over 6 factorial plus x to the power 8 over 8 factorial and more. But we find the first four non-zero terms. That means just need only the first four terms for the estimation. As x equals 2, the function at 2 or the cosine of 2 is approximately equal to 1 minus 2 squared over 2 factorial plus 2 to the fourth over 4 factorial minus 2 to the 6 over 6 factorial. So the cosine of 2 is approximately equal to negative 13 over 15, which is about negative 0.8666. This example, we are going to represent the function as a power series. Let the function f of x be e to the x minus 1 divided by x for x not equal to 0, and the f at 0 equals 1. Use the Maclaurin series for the function f to evaluate f prime at 1. And then find the value of the series k over k plus 1 factorial for k from 1 to infinity. First of all, we're going to find f prime at 1. For the function f of x, we can rewrite it as 1 over x multiplied by e to the x minus 1, and then replace e to the x as its power series or the Maclaurin series as 1 plus x over 1 factorial plus x to the second over 2 factorial plus x to the third over 3 factorial plus and more, subtracted by 1. Simplify the function by canceling 1 and negative 1 and multiply all by 1 over x to get f of x as 1 plus x over 2 factorial plus x squared over 3 factorial. If you repeat the patterns, that would be x to the third over 4 factorial plus x to the fourth over 5 factorial and so forth. To find f prime at 1, we're going to find the derivative term by term. The first term going to be 0. The next one going to be 1 over 2 factorial plus 2 over 3 factorial times x plus 3 over 4 factorial times x to the second plus 4 over 5 factorial times x to the third and so forth. So f prime at 1 is the value 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial plus 4 over 5 factorial and so forth. So the f prime at 1 can be rewritten as the Taylor series or the Maclaurin series in this form. And on the side notes, for the function as f of x equals e to the x minus 1 over x, if we do the direct derivative to the function, use the quotient rule to find the derivative. We have x multiplied by e to the x and then subtracted by e to the x plus 1 divided by x squared. So then the f prime at 1 would be 1 multiplied by e to the first minus e to the first plus 1 divided by 1 squared, or we can see this as the value 1. It means the f prime at 1 or the value 1 can be rewritten as the sum of the terms 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial plus 4 over 5 factorial and so forth. So the real number can be represented by the infinite series or the Maclaurin series. And in the second part, we're going to evaluate the value of the summation of the k over k plus 1 factorial, k from 1 to infinity, which is the same as the series that we obtain from using the derivative of the f by using the Taylor series. That means the summation k over k plus 1 factorial is exactly the same as the value 1.